how you can easily generate that. Basically, either directly setting the microcontroller itself, or you can just program it through MATLAB Simulink. So I gave you the user sort of a good guide to do that. I don't know if you had a chance to finish that module. Yes.
I did that module, but we did it on somebody else's computer. I tried to install that package
Yes.
in the manual on there, and it kept trying to back it up, and then it freeze when we finished the line of backing it up. I did it like 3 times, and it just keeps doing the same thing.
So you have the MATLAB,
I have that, and I
and
have
then
the
you
program.
need three programs.
Yeah, it's the.
So one
I think
is
it was
the target, one TI, and
There's
then you
one
need
TI
a
one.
compiler. So you need like 3 programs. So which one?
I think it was the second TI one. There was 2 TI ones, right?
Two
You need
TIs.
the
Yeah,
CWware, you need the
Studio.
actual,
It's
the
a
studio.
Studio kept trying to back up, and like, it'll like finish the line, it'll be like a green line, but it'll never actually finish.
Just
It'll just be
Studio.
continuing forever. And like, I go look on the CPU and it says, no activity going on, and it'll just keep doing that, I uninstall it, run it back, and then restart the computer, did like 3 or 4 times, and it just keeps doing the exact same thing. Like, it'll finish it and then just freeze when it tries to back it up automatically. So I don't know if there's a way to not back it up, like, I don't know why it does that.
Basically, it's not installed, right? I mean, I
Yeah.
don't know how, like, do you have,
Are we allowed to just use our own microcontroller and make a PID?
let me get.
Of course, sorry, I just altered this.
Oh.
Is it CCS 12.5?
Yeah.
It might be a dependency issue.
I know that they wanted me to install 12.2, not 12.5 for CCS.
For Code Composer Studio.
Did you follow exactly
It
the
did support
routine
12.5.
Your breed manual?
MATLAB did. Yeah, when I
Yeah.
did the dependency check with the C2007.
Because Code Composer Studio.
Which
runs
drive did
the
you
code
try
on
to
the-
install? C?
That's the
or-
secret about like every ID. They offer it.
The other problem is like the block.
I don't think it's the actual software stuff, it's the mechanism it's trying to do to back it up for some reason. I don't know why it keeps doing that. Cause it'll install it, and they'll say back up, and it'll freeze.
Did you restart the computer when it asked, and then do it again, and then restart again? Cause I had
Well,
that.
it never finishes when it backs up. It's like when it's on the screen, and the screen just
Dude,
keeps
if it's
going.
like a dependency issue, those bugs are so fucking hard to fix.
Yeah.
Like if it's one that just isn't there. I had one like that on like Fidus, and thank God Zach ran into that issue like 5 years ago. And like took this. Cause he had like sent me like, it was like a terminal command to like install the library.
Yeah.
Basically, the program relied on a 32-bit library that since got changed to a 64-bit library. So I can like go back in time with like the 32-bit things.
So I was talking to Joey, basically the C2000 codes and the 430s are discontinued, and like they're not supporting any of it anymore, so we just need to get newer boards. Like that's, they have drivers for everything, new ones just do the bad drivers, you don't need any of this dependency.
What is?
So basically, you don't see this, right? So this-
They're working.
No, the tabs pop
They
off.
have to resolve the.
So you have the embedded coder?
I have the embedded code, I don't have the,
That's what one they wanna go with, but they might
I
just do
don't-
it.
I have the PWM, I can draw that block over. I don't have the other 3 components to actually run that, Simulink.
Embedded, no.
I have the code composer on there, and I have the first one of the TIs, where you have to restart the computer. The other one just goes in the independent, just trying to install the studio.
Same thing, this is just a PID, it's nothing complicated.
I got it to work on another, my partner's computer, but I tried to install mine multiple times.
No, I think it's good that you tried, because, but I don't know, I've never
Someone will have to,
encountered that issue.
I think we had the same issue too, but
We just kept
we,
running.
yeah, we had like, I think what we did is we took the helpline and then
PI.
One of the classmates, I think his name is Danny, I think. He won the issue, but he helped us fix the issue, but that was like.
You gotta help,
That was like 2 weeks ago. What?
you gotta help borrowers.
Yeah, we had to get help bar, and then it's someone at help bar, you take it to this other drawing, and then it kind of retraces those steps and helps you fully down. But
Cause mine's is stuck in installation,
yeah, so it was a
the studio.
CC Studio.
Yeah.
We're starting 5 dash videos, attempting
Where
to.
is it? The
So, was there any,
Or my Windows
like,
computer, not my Mac,
yeah, install
this is
first,
my
like,
old
C2000 and then,
But they take a
So
long
I
time.
went ahead and
Version
installed,
of
CCS, I installed
Oh, yeah.
CWware, and then, dependencies from MATLAB. So I got those through here, and then I went ahead and,
Yeah.
And it just freezes again.
did the
I'm
C2000 setup
installing it from-
inside
so there are
MATLAB.
two ways you
Once
do
I
it.
did that, it
So
opened up a new window,
every
checked for
go to
dependencies, and I had to
MATLAB.
reinstall, because I had to have 3.49 on it.
So you go to MATLAB, there's other things.
Basically, everything in the manual was wrong, and I had to change it, that was the only way to do it. And that's what MATLAB said, it had to listen to MATLAB. Once I got all that done, then it worked on a window. Because, yeah, I have hard drives.
I kind of want these things like not compatible.
Yeah, I got it to work on my computer, I did not get it to work on my computer, because it doesn't have hard drive.
Those computer engineers, they have things that they got. What did they know? They got it.
Well, that's,
It was always the like hardest.
When I saw
Yeah, our
47
setup
hours
was
for
worked
install,
out for running the,
yeah,
resistor.
they were completely.
That's another issue with the resistors don't-
okay, so let's continue, I think we will go back to this. Yeah, you can use your own microcontroller. Even you can program it. This is, as I mentioned, there are multiple ways. But just keep in mind, when you wanna get help from TA or myself, then basically we are a little bit maybe slow in that sense, right? So basically right now we need 3 modules, right? So today I'm going to talk about the ADC. I understand that you learned ADC before, or the concept. Here we want to use a tool to basically use the ADC channels. Why do we need ADC? Because you have sensing board, you measure voltage, you measure current, and these are analog values. And in a microcontroller, you want to add your own firmware to generate the PWM. So in this case, you see that the PWM are just open loop. So you set the duty cycle. Now the goal is, by doing feedback with voltage and currents, you make that smart decisions to change that. So in other words, it's pretty simple, right? I mean, even programming it directly, you just set the ADCs. But here we try to go through some practical aspect. So the implementation is pretty simple, you know? So you just go and bring the ADC block here. That's it, right? So you don't have to do any coding. And what you need to do is, basically these are all set up, right, I guess? So, and you just have to basically select the ADC channels you want. So basically, again, you go back to your user manual of this launchpad or this microcontroller kit or your own microcontroller. You just wanna basically understand the pinout. So here, basically you're looking for this, right? So you see, so the pin number 29 is ADCA2 channel, or you can basically select any of that. So a couple of things are important when, I think the overall concept of ADC is what's the resolution of ADC, okay? So, what's the resolution of ADC in this kit? Anyone?
12.
Right, so it's 12 bits. So basically you look at the whole range of acceptance. In this case, what's the maximum voltage that you can insert to this board? You can apply.
5 volts.
So 5 volts is a max that we have on the supply voltage. But now you have to go into different components and see if there is any absolute value that you can get out of this. Alright, so what's the maximum voltage that the ADC channel of this particular microcontroller can take?
Is it 3.3? I didn't look
I don't know, I'm asking.
I thought it was 5, but I.
Is that 3 volts or 3.3?
it. 3.3.
Is that 3.3? So all of this information should be there, right? So what's the minimum voltage of the ADC or the input for this microcontroller? Minimum voltage.
0.
Right, 0. Right, so it's unipolar. So 0 to 3.3 volts. So whatever you measure, whether it's voltage, current, temperature, wind speed, motor speed, when it goes down to the voltage that it's read, suppose it should be read in the microcontroller, should be within 0 and 3. Okay? So now the conversion is, you want to convert a value between 0 and 3, spread it out over basically digital values or your bits. So essentially, you would say that what's the equivalent of, let's say, 3 volts if you have 12 bits, right? So if you put all of them 1, it's full, right? So it's basically 2 to the power of n. Does that make sense? So now if you are interested in any value smaller than that, you go with the proportion. So now if it's 1.5 volts or half of 3.3 volts, right? Basically you put that number divided by the max value or the reference voltage times whatever bits you have available in the system. So in other words, if the equation is the conversion, basically is pretty simple, right? 2 power of n times the input voltage, right, from your sensor board divided by the reference value. Okay? So this is your ADC result, right, that you expect to get. But in this case, you can have a floating systems, you may have multiple ground systems, right? Therefore, you define the ground or the potential where you're reading based on that, right? But in the simplest way, V ground is your common ground everywhere, so it's 0. So you have V input, whatever the sensor board gives you, divided by the reference voltage, that gives you the proportion, times the number of steps, right? Or basically the position of that. So this is really the essence of ADC. So again, it's pretty straightforward. If you want to program it, you just have to go through individual microcontroller, understand the coding, how to set it. You don't have to actually program anything. You just have to adjust the setting based on your need. So as you can see, you just select the conversion channel. I assume that everyone has this like this package now installed. So in this case, I just chose ADC input number 2, right? But now you are getting an analog signal, right? Essentially with no time, right? And now your ADC needs to trigger at certain time. So it's very common that you program that in your firmware. So one of the main synchronization is your main PWM signal, for instance. So it shouldn't be that necessarily, but it can be multiple of that, it can be average of that, or it can be phase shifted of that, but synchronized, right, with your PWM generation. So in this case, this is set up, right? And now you can put inputs to the pin and see what your software is reading. So for that, essentially what you need to do is you have to go to this user manual, and here you see that which pin is that. So is 29 on J3. So which one is that? J3. So on the left corner. So here we can just do that. So you input and you can read it in the software. So that is perhaps if you want to develop that, it's very lengthy, but here it's very simple. The challenge that we have in general, and perhaps you appreciate it more when you do the closed loop of our system, is that these ADCs have some non-idealities, right? So therefore, what you get inside the microcontroller is some value that you have no access to. So you put in 2 volts and you assume that it's 2 volts, right, inside, but it's not. So maybe it's 2 volts, but gives you 2.5 volts. So basically the only thing, right, that we have to basically adjust, we call it, we calibrate the ADC channel, and this is common. So you cannot, basically, in my experience, go with no calibration. So you have to calibrate. Basically, if it's 2 volts, you have to make sure it's 2 volts. And if it's not 2 volts, right, you make it 2 volts, virtually, right? Because you know how much you put in, right, as a reference, so the true value is known for you now before you put it in your system or integrate in a power converter. So you assume that, okay, I am now putting 1 volt in this pin, and I want to make sure it's 1 volt. So how do we do that? Basically now, either the microcontroller comes with it or not, we can use an analog output of this, or you can develop a digital to analog conversion. So this can be a separate component, can be integrated, or at high speed, actually designers design their own DAC. And this is very actually applicable for, they call it mixed signal, maybe you've heard about the term, right? Mixed signal control, that if you have a very high, fast parameter and slower parameter, right? And microcontroller may not be good enough for that fast transients. Basically, you do the slow dynamics in the microcontroller, right? You get the reference from the microcontroller, you convert it to an analog, and then compare it with an actual feedback of that fast transient. The example is actually a PV system, where the voltage of the PV panel changes very slowly, but the current can be as fast as the switching frequency. So imagine that if the switching frequency is set at 500 kilohertz, your microcontroller may not be able to react that fast, but voltage is basically sun, it's like millisecond max or even seconds or minutes. So for controlling the voltage, you're using the microcontroller, right, generating the reference for the current, and then have it in the analog domain. Yes.
Do we need a logic analyzer for that?
Logic analyzer?
Yeah, because to see that waveform would be something that's
Oh,
beyond
yes,
skill,
yes,
right?
yes, we do. Yeah. So basically for those applications, we use microcontroller to basically have the supervisory control and slow dynamics, and then we use CPLD or FPGA, right, to generate the switching signals. Okay, so basically we do all of, so what I meant was we only need that ADC section, but this ADC has little value for us except that we can just run it. That's the main thing, but that's not enough. So to check the ADC, we have to introduce the DAC, meaning that the value of the digital signal here now residing in the microcontroller, right, in the software, we put it in the DAC or digital to analog converter, and you want to see in the output, okay? So now, in this particular microcontroller with 12 bits, what's the maximum voltage, or what's the maximum value that I can get in digital? So here I put 1,000. What's the max?
Well, we have a 12-bit ADC, so that'd be 4,096 minus 1, so 4,095.
That is correct, right? So basically, so this is where your DAC saturates, okay? And any values beyond that, basically we don't care, right? So there's no harm to the system. In this game, you actually may harm your, you damage your conveyor, or basically setup. Any question?
When we tried to do the sort of lab for 5-2,
Yeah.
we ran into a few problems. So we try and follow the guideline that was given to us. We followed it, and it tells us to add the.
Which guide are you on?
Oh, sorry.
Which manual are you on?
The first one was just like add the ADC on there.
So let me finish this, then I'll go to the 5-1, because this is the general ADC setting.
Yeah, that's the 5-2 one. That's 5-2. That's,
Oh, okay.
yeah, it's just our ship was like our clocks isn't communicating with the Simulink, so there's no communication between. So it just says the target is like it's not connecting, even though we've been using the same simulation since 5-1. But it's not giving there's no target. So we're just stuck on there. We tried different,
Well, have you, so, did you try, you know, the simplest one, the serial communication? Have you built this?
yeah, so we're trying to follow along, but like, in the.
No, without making it even more complicated. Could you get that? Like what I did last time?
The red and blue?
Yeah,
Yeah, that works.
so that works. Then you went on to the EPWM and that works
That
too.
worked really well.
And now and you build DAC with the same setting.
Yeah, and it says it does not, target does not exist.
Okay.
follows that instruction, he's not happy exactly the way that it's set up.
That's interesting. So let's see, maybe I get the same error. Haven't tried it in a while. Okay, maybe let's try this first as the simplest. So let's not complicate things. So did you try this? Just that.
Yeah, we have that, but for some reason our display, like, I guess we're focused on display. So what is it supposed to show after you click the monitor? Should it show anything, or does it not show anything? Display button on top.
This one?
Yeah. Should it show anything, or?
No, I mean, you have to put, like, basically you have to add an index to it.
Yeah,
right?
we added 29
To
and then
30.
to 30, that's what we had.
Yes.
And then we ran it, and it's just, it doesn't exist. The target does not exist, that's what it shows for us.
Okay.
And we've been stuck there since.
So let's run this. Let's see. Let's see if I get this same issue. Do you have a better browser?
I hear you.
This is better. Good.
So it's funny. It's funny that this one.
It's continuous, right? But we don't have it. It's continuous.
So multi.
It's
multi-
It's for,
I'm thinking of October. There's law from October. They're gonna like, it's like gonna have to collaborate and stuff.
And then you got that, right? It's like, it's like.
He's gonna get some.
You wanna get it? If it's in there.
Would you like this?
It had.
Yeah, it should
It
come. Let's compile it.
Send one blind.
Oh, this is one to five. One of these is hard.
Yeah. Yeah, it's a first.
Here we go. So this is gonna be our first March Madness coming up?
Probably.
That's great.
Yes, it's fast.
We'll be a farce in that.
That's what I'm saying.
We'll be a farce in that.
Probably the first ones up. You would. Why it was moved this up. We couldn't win a game in YouTube.
Are you serious?
Yeah, it was always like, we win everything.
Hey,
overtime, and they're like 82.
No, wait.
Is that what we said on Saturday?
Uh-huh.
No, we should.
No, we're almost lost. We lost in
We
overtime.
lost the lead, bro. The whole time when I was here, you were up like at least 7 points, bro. I was like, bro,
You were clearly a good low.
we were clearly like, you know what? I think that's it. I should have stayed. Like,
You should have stayed, man.
I should have stayed.
Yep.
The fact that we played that good against them, after getting destroyed,
That's what they need me over there, but I'm like, I can't do it.
no, they need your good brother to losses.
What's your flavor season?
So try
You
30.
losses out there.
Sorry.
That's fake, I mean, I'll say, no, he's too soft, so he's, I said left tackle.
Okay, that's fair.
Just put a booger, just booger. I'm gonna burger, okay, we got it. He's like, oh yeah, we'll get that.
You know, kid for a burger by accident.
Honestly, his body type and this position.
On his
I
next
like
line,
major
major
line
line.
on that.
You're gonna get it. Yeah, bro.
Like, we got this one, I think it's fucking dog. 6'4", 220.
Yes, sir.
I would suck at pretty much every position.
So what?
I would suck at every position.
His center.
I was about to say center, not like higher, like competitive leagues.
No, we don't.
You obviously would play for college, but like high school football team, they could be center, low to the ground.
We change it to
Low to the ground.
Discipline form, low to the ground.
Appreciate you.
Biggest heck, man.
So till this, you didn't have issues, right?
Yeah, so I did that first part, that one
That's
worked,
all.
and then after comparing to 29 and 30, I was having issues, it says the differences.
Run, dude, power through, dude.
Low to the ground, bro.
Low to the ground.
I'm just going between people's legs.
Strong, fall forward.
What the?
You ever seen that, they got one?
You got more than that.
Oh, I love it. Yeah, pretty good.
Did you go all the way down?
You going home? You got a red beet mochi? You gonna get some pretty good? We're in that trial phase right now.
I didn't think you were that freaked out with it.
Anything else like that?
Alright, I'm gonna go
Yeah.
take some good spin. Those are good.
All the back.
What else they got?
I love mochi.
Yeah.
I
Okay,
love
so
it.
now it's working.
Nah,
2.24 volts.
this guy.
2.2. 3.2.
My red bean emoji.
So basically here, what I did is put the maximum value, right? So like 4095, put in a DAC here, have the connection read as, I think, pin number 30th on J3. So here when I had 495, essentially it's like 3.24 to 28, right? So it's maxed out to 3.3. If I change here, change this, so you expect this drop, right? And you read this. So why do we need this? Basically, we use this as our reference to calibrate our ADC. Okay, again, when you start, you may not need this. But basically what that means is if you measure 10 amps, your microcontroller sees that at 11 amps, for instance. So whatever that does to your controller, you take that risk. So the only thing I want basically to emphasize here, we make a mini closed loop here to calibrate our ADC channels. So this work was, in a way, unnecessary to develop our closed loop control, but essential in a way to calibrate our ADC channel. After we're done, we just disable this part. So to do that, basically we take the DAC output and use it as an input for our ADC. We change the input for the DAC, right? We turn it to ADC and read it, and that's a good example of the full closed loop to see if we see the same number. Okay, to do that, we connect 29 and 30.
I like to make sure I know when I drink, sometimes there's some confusion.
So basically, I short 29 and 30. Okay? So the pin number 30, if you look at the manual, right, is the DAC out. And pin number 29 is the ADC input for that channel, A2. Alright, so let's go see if I get that error. Target is not found.
Then you're right.
Okay. Well, I didn't get that error, unfortunately. But again, I urge you to repeat this, like without creating again. Do you save as the document or you
Yeah,
move
my
the document?
teammate, my teammate has the simulation, but when we follow along on the ADC guideline, I don't remember putting the TBPRD and the CMPR on there. I don't have those two on there.
Well, this can be, I mean, I made it like this, but TBRD is, you know, the switching period based on the clock.
Yeah.
So either you can put it as an external component, like you can adjust it, or if you use a fixed value, you can just put it internally, right? You know, like, so you're not doing variable frequency. So that maybe actually, because for the ADC, but you just have to make sure that you define the start of conversion for module A, right? And here, that affects, not sure.
Yeah, I mean, yeah, cause, yeah, when we go along in that, what's it called, we put all values,
Okay.
yeah, for the first one.
Okay. So here, basically, this is what I wanted to show you why we're doing this practice. So you see on the DAC, I have 1,000. Put it in the output, right? Bring it back to ADC and see what's the value, right?
Yep.
So basically, you put 1,000 in the output, you get 1,085, right? So basically, if you just look at this number, right? You're saying that, well, if I have 1,000, I see this number, right? So the actual number is this number minus the difference. So that's one way to look at it. But you can now check if this is true in all the numbers. You see now if you have 2,000, you double that, but the difference is not doubled. So you go from 70 to 100. If now you go to 3,000, right? So it's not really doubled or triple. So in other words, this constant value may not be the best option, and of course, there is no rule to how to calibrate it. So therefore, what we do is we go with basically average value, right? What you expect to see, if it's the current, if it's bipolar, what's that value? If it's unipolar, right? So you go with different values and calibrate based on one coefficient and one bias point, right? So an example, for instance, I did that with 0. Right? In this case, it's 43 with this microcontroller, and I did that before with another microcontroller. For every microcontroller is different. So previously it was 7, now it's 40. So I subtract from the 0 value and then calibrate based on another value that is most important for me. Okay? So for instance, you know, the mean value that I was looking for, right? If it's 0.3, 1.5, what was important for me? So half of that. Okay, and what I read and what I get. So with this practice, essentially you try to make them as close as possible, right? And this is only ADC calibration at one temperature. So imagine that if you want to build a system, you have to do it at multiple points, different temperature, right? So in other words, it's not a unique exercise, and that's the reason I said I like that you copy from each other, because even I cannot go from one microcontroller to another one, basically you don't get the same result. Okay. So I think this is, to me, this part is the most important part. Now you can read the data effectively. You can generate the PWM, right? Now you can calibrate it, and the rest is basically your Simulink block that you can translate, okay? And I'll try to maybe do it next time, or maybe we do it in the lab once with our own Simulink to show you this. But I think for today this is good enough. I really want to emphasize on ordering your printed circuit board, your PCBs and components, If you haven't ordered your components, you're late. So basically by today, you should have ordered your components, right? I'm not talking about your PCB, your components, as I mentioned earlier. The adjustment of component is less than 10%, you see that. But the sooner that you order your PCB, the better, because then you have a chance to revise it. This part is software, you know, you see I can just change one value, you can test it, right? Hardware is hard, right? So it's not instant, yeah.
So essentially, we're just making sure that the value that before it goes into the EPWM is the appropriate modulation.
So this is good enough to basically build your system, right? And you can run it, okay? Later on, what we need to do, we should add, so with the ADC now, you can read your sensing parameters, voltage, current. So let's say you want to do your closed loop based on current, okay? So you read your current value, you bring in the ADC, then you don't have to worry about the digital or analog, it's already in the Simulink. Then you build your closed loop, whatever Simulink block you used before, PI, okay? The program takes care of it, and that should give you this. So here, you see it's a constant value. But actually, this is variable, especially when you do sinusoid. Right? And you have tested it, but for closed loop, you have to make sure you don't set that. It's coming from your feedback. Okay, any question? Any concern? That's more important. Are you guys all good with the timing?
Yeah.
What was our harmonic maximum distortion? 5%?
Yeah, what we get is lower, but yes, yeah,
Okay.
because we use additional. So from now on, again, there is no due date. We only have one due date, which is your final exam, right? This is like the last day to check out your lab saves. And if you can show me today, you're done.
Oh, you'll be there for check out?
Yeah. So if you can have your printed circuit board ready to connect. So in my opinion, if you can start on 5.2 as soon as possible, right? Then you understand this portion of it. Then you work on your printed circuit board, and meanwhile, this is not related to this, then the integration. So in the past, 90% of students delivered or submitted their results before their final exams. So only a few went out, during final exam. So I'm hopeful you can do that as well. The only problem is the Thanksgiving break, so I don't know if you guys are available or not, the question. Anything else? All right, so I'm available on Thursday as well. Maybe I'll talk a little bit about Interrupt. And I think that's it. Yes.
No,
All right.
just good.
Thank you.
Thank you.